Okay, here's part A of chapter 9 review for Aubrey and whoever else wants it. We're going to start with 9-1. I'm going to change the number for number 1 because I don't like 4 and 4. It leads you to believe that this is a thing. So let's do 4 and 12. I like it. Good job. 4 and 12, okay? And it says, find the geometric mean. Geometric mean is not like the regular mean. If I find the average of 4 and 12, I add them together and divide by 2, that would be 8. Regular average. I'm going to write this down. You don't write this down. The regular average would be 4 plus 12 divided by 2, which is 8. Don't write this down. I'm telling you, don't write this down. That's the regular average. That is not the correct answer. The geometric mean means this. If I have this in such a way where I have like a triangle going on and I would end up with a proportion that looks like x over 4 equals 12 over x, right? How do you do that?
You do math. 48.
4 times 12 and x times x, right? X squared equals 48. Do you see that? How do I find x? You can write this part down, yes. You take the square root, and the square root of 48 is something. Somebody give me the square root of 48. It's like 6.93. That is the geometric mean. The regular mean would be 8. The geometric mean is 6.96. They are different. So make sure that you know how to do that and you are writing that stuff down. Those should be free points. It's not a hard process, right? Okay, you do number 2. I will give you 30 seconds. Go.
Why is 4 on the bottom, but...
It doesn't matter. You can put 4 over x and then x over 12. It doesn't matter, just as long as the 4 and the 12 are opposite.
Okay.
Sure.
So it's gonna
Like
be
this?
x squared
Sure. Sure. Okay. All right. So
square root of 20.
you do number 2. Go. You need one. You have a calculator on your phone. At least do that.
That's hard.
Then it'll be great.
No, I don't play games on my phone.
12 squared.
Okay, are we done?
No.
Number 2, if you did the regular average, again, don't write this down, but if you did the regular average of 4 and 6, what would that be? 5, but that is not the case. If you do like x over 4 equals 6 over x, x squared equals 24, and you take the square root, it's going to be a little less than 5. 4.9 what? 0?
Yep.
There you go. That's the average, not exactly the same as the regular average. It's the geometric average, yes.
DQ has blizzards for 85 cents right now.
I
Cool.
saw that. Can we
I don't care.
class field trip?
Okay, are we happy with 1 and 2?
Like
80 cents.
Yeah, yeah?
I'm going to DQ.
Wait,
They're
wait,
going
wait,
down.
that's crazy.
Okay.
So if I buy 2 blizzards, then I'll...
Wait,
Then they're
who's
both
gonna go
85 cents.
Macy, I'll go with
So
you.
could you theoretically buy 2 blizzards?
Strawberry slush.
Wait, Mason.
And a
All right, number 3.
Buy 2
Find x, y, z. Here's what I want you to do. Shh.
because you spend $1.
Wait, if the regular blizzards are $4, you're paying $4.
You want another one? Make it
I was
5.
gonna say, there
No.
was like $3 or $4. Like, Don, are you really telling me that there's like $4?
Okay, hey, I'm on number 3. Get to going. Or you can do this by yourself. I don't care.
No.
Okay, then get your butt going. Number 3 has 3 triangles in it. Do you see all 3 of them? Yes, the small, medium, large. Okay. All right, the small guy is over here. What is his shortest side? The small one. So I'm going to label him as a 2 down here. What's his tall side? X, and his hypotenuse side is Y. Do you see how that works out, right? 2xy, right? Okay, now we're moving on to the medium-sized one. And that is like this guy right here. His short side is X. His tall side is 5. And his like long slanted side is Z. Okay? Then we have the overall big guy. And his short side is Y. And his tall side is Z. And his slant side is 7. If you separate them out like this, it makes it way easier to find things. All right, so would you like to solve for x, y, z first? Sure, x. Okay, I see an x here and an x here, which means we're not going to use the large triangle. We're going to don't cross him out, but like in my brain right now, I'm like not using him, right? Okay, now if I use the small and medium one right here, x is here and x is here. So what other 2 sides do I have to use? 2 and 5, because if I use x, 2 is across from x, if I use 5 x across from that x, right? So the short side and the tall side is what I'm using, right? Now, how do I solve for x? Proportion, just like we did up above, right? X over 5 equals 2 over x. We can do it that way. Who wants to go like x over 2 equals 5 over x? Yeah? Does it matter? No, you can do it that way. Okay, so we do our little circle thing. 5 times 2 is 10, and 10 equals x squared, and then we take the square root, and the square root of 10 is 3.16. Perfect. There you go. That's x. Then we move to y. I'm going to erase while you write that down. Okay, are we ready for y?
Yep.
No?
If that song were a man, it would like us.
If that song were a man, it would be James Charles.
Okay, y is here and, whoa, hold on. Y is here and y is here. Which one are we not going to use?
The middle one.
The middle triangle. We're going to cross him off in our brains right now, right? Okay? And if we use that, what other two sides do we need? Shh. What other two sides do we need? I need 7 and 2. I need the short side and the hypotenuse side. Do you get why that is, right? Okay, we set up a proportion, so something over something.
Why'd you cross out the middle box?
Because that's the triangle that we're not going to, don't cross him off. But I'm like in my brain, I'm crossing him off because I'm not using him, right? I'm just using the small and the large. Okay, what over what?
Y over 7.
Y over 7.
Okay. 2 over y? Ella does not like doing it that way. 7 times 2 is 14 equals y squared. And we take the square root. And that is?
3.74.
Perfect. Equals y. There we go. Okay. You write that while I erase.
Yeah, I'm not writing this down.
And then they like,
What's that? Yes. 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 That's it. Your calculator. I don't know. I just wrote out the whole thing. Right? Because if you take y times y, that's y squared, right? And 7 times 2 is 14. So 14 equals y squared, and then take the square root to find y. Yeah, good. Okay, z's. Z's are here and here. Which triangle are we not using? Small. What two sides do we have to use? 5 and 7. Okay, what over what? Z over 5 equals 7 over z. Sure, that's one way of doing it, right? 5 times 7 is 35 equals z squared. And then we take the square root of 35, and that is almost 6.
5.92.
Perfect. Do you guys like check that in your brains? Like, hey, I'm taking the square root of 35. Oh, that's not quite 6, right? So you know if you type it in your calculator wrong, right? You're checking it a little bit in your brains. Okay. All right. Yeah? Okay, find x. How do I find x? And don't say here it is, Kellen.
Did I say that? Did I say that?
Don't write that down.
Have I said that?
I don't know.
Can you go back?
I've had people do that before, though, when they don't know what to do. They're like, here it is, right?
You want to go back to the other
All right.
Wow.
Is X 3?
X is not 3.
Whatever that means.
Okay. I think on this one, you don't necessarily have to use a perfect triple. They want you to just do the Pythagorean theorem. Okay. How do I know I can use the Pythagorean theorem? What is the Pythagorean theorem, by the way?
Right triangle.
A squared plus B squared equals C squared. Write that off to the side and put a box around it. We're going to do any formulas that we put on this sheet. You're going to put a box around so you can find them, right? A squared plus B squared equals C squared. Now, on number 4, which side is side C? X has to be side C. This can be A, that can be B, it doesn't matter. So 3 squared plus another 3 squared. 3 squared is 9 plus 9 equals C squared. 18 equals C squared. And that is the square root of 18.
4.2.
C equals 4.24, right? That is perfect. Actually, I would probably rather have that, but I understand that people don't remember that. Okay, this is a 45, 45, 90 triangle, by the way. So if you remember this, right, every 45, 45, 90 triangle is 1, 1 square root of 2, right? So this is 3, 3. This would be 3 square roots of 2. But 3 square roots of 2 is the same thing as 4.24, Actually, 4.24 is the rounded version of 3 square roots of 2. But there's that. Whatever. Okay, we'll write those down here in a bit. That's on 9.3. Okay? Number 5.
You found C, not X, because you said C equals not X.
Oh, I'm sorry. X equals. X equals. We'll rename him. Okay? All right, number 5. Can you use a squared plus b squared equals c squared? How's come?
9 squared.
It's a 3, 4, 5.
He is a perfect right triangle. He is a 3, 4, 5. But let's say you don't remember that, so you can do, which side is side C, by the way?
25.
15. So 9 squared plus x squared equals 15 squared, right? A squared, b squared, c squared. Okay. 81 plus x squared equals 225. And if you subtract 81, you get 144.
And then it's 12.
And then you take the square root, and it is 12. But that is a 3, 4, 5, just upscaled. What's the scale factor of it? 3. It's multiplied by 3, right? A 3, 4, 5 multiplied by 3.
You can.
Okay, are you writing this down?
Yeah.
Okay, you best be doing that. Okay,
What?
all right. That is number 5. Number 5. Okay, all right, good. Ready for the next?
Fine, if you don't want
You can tell me no if you're not done. Okay. Determine whether it is a right, acute, or obtuse triangle. Okay, so 30, 40, 50. Is that a 3, 4, 5?
No.
I don't know. Let's figure it out. So which side would be side C, by the way?
It is.
50. Is it always the last one that they list?
No, the big
The biggest one. Okay, so let's go 30 squared plus 40 squared equals 50 squared. Let's see if that is true, right? 30 squared is 900. 40 squared is 1600. 50 squared is 2500. Is that true? So is this a right triangle? What's the scale factor? That's a 3, 4, 5. What's the scale factor? 10. It's just multiplied by 10. It is in fact a right triangle.
Does that work? 4 plus 9 equals.
Now, here's what is not true.
It's not 1.
Brady. This is what was floating maybe through your mind.
No, I was just kidding.
The square root of 3, don't write this down. The square root of 4 and the square root of 5, is that a 3, 4, 5?
No.
No, that is not a 3, 4, 5, right? Square roots do different things. That's not the same thing, right? It's not the same thing as multiplying by whatever, right?
Wait, I have a question.
That is not a 3, 4, 5. Yes?
How can you tell it's right just by that?
Because a squared plus b squared was equal to c squared, and it worked out, right? 900 plus 1600 is in fact 2500, so a squared plus b squared equals c squared, which means it's a right triangle. Okay, hold on, we'll get to that. In the next one, number 7, we're going to see that right now. Okay, so which side is side C in this case? 40. This has to be C, so I'm going to set this up. A squared, 20 squared, plus 30 squared, and 40 squared, okay? 20 squared is 400, 30 squared is 900, 40 squared is 1600, right? Okay, are you ready?
Not equal.
400 plus 900 is 1300, okay? 1600. Hold on, listen to this. This is the important part. 1600, this was my biggest side.
It's an obtuser.
My biggest side. Is my biggest side a big side or a small side?
Big side.
Big.
My biggest side is big because compared to 1300, my biggest side is even bigger than that, right?
Massive.
When your biggest side is really big, is it acute or obtuse? Obtuse is going to have a really big side, right? Okay, acute is going to have a tiny side, even if the biggest side is whatever, right? Acute, obtuse. So this is obtuse. Does that make sense? My biggest side is a really big side, so it's obtuse. Got it? Beautiful, beautiful. Okay. All right, 9-3. Off to the side over here, we're going to put some stuff in a box. This is a 45, 45, 90 triangle, and we're going to put him right here, and you're going to put a box around him. 45, 45, 90. 1, 1, square root of 2.
Yeah, and then the other one's like.
Okay, hold on. Put a box around him.
Why?
This is a formula. You need to remember this guy.
Yeah.
Okay, 1, 1 square root of 2.
I might as well write him down.
That would be a good idea. That would be a good idea. Okay, so number 8. If this bottom side is 8, what's this side right here? 8. What's this side right here? 8 square roots of 2. It's just multiplying by the, base side. My base side of 1, 8 square roots of 2, right? Now, you could use the Pythagorean theorem for that and figure that out, right? But since we know the cheater method, which is this guy right here, we just get to skip the steps, right?
It's
Okay?
11.3.
Perfect.
No, it's not.
Okay.
I just did the method.
Yeah, it is. Okay. All right, over here.
What does calc mean?
Okay, when I look at number 9, shh, listen. When I look at number 9, these two sides are my one side. This is my square root of 2 sides. So how do I go back to this side?
It's 3.
You divide by the square root of 2. What is 3 square roots of 2 divided by the square root of 2?
4.
It's just 3. Does that make sense that that would be a thing, right? Ah, right? Okay. Okay. That was number 9.
Calvin, did you need your calc for that?
Good?
No.
Good.
All right.
This is Gummitry did it before.
I was taking notes, Trevin.
Sure. Okay. All right. Here's the next one. This is a 30, 60, 90 triangle. Label him off to the side because we're going to put a box around him. 30, 60, 90. And these are 1, 2, and square root of 3. Which side's the 2 side?
Big side.
The hypotenuse. And this is the square root of 3 side. Okay? Put a box around him because he is like a formula that you need to remember. 1, 2, square root of 3. 1, 2, square root of 3.
X equals 1 and y equals negative or
Shut up,
square root of 2.
Right. Okay, so on number 10, which side is the 1 side?
The 1/2.
The 1/2. Which side's the 2 side? X. Okay, so the relationship between those two, whatever this guy is, this guy's double that, right? So if it's 1/2, X is 1. That's the answer to that guy. Okay? And Y is the square root of 3 side. Okay? So I take this side and I multiply by the square root of 3. What's 1/2 times the square root of 3?
12.
1/2 square root of 3.
0.866.
Or, so this would be fine. Okay? Or the square root of 3 over 2 is sometimes how he will be written, right? Does that make sense? If you lump him on the top, the square root of 3 over 2 would be fine, right? You will see him quite a bit.
So, the square root of 3 is always
What?
times the bottom.
No, this is like the square root of 3 over 1. Oh, the square root of 3 is always times the base one, yes. Which is the bottom one.
I wish I was.
Okay? Good.
Zach drew on me.
He drooled on you?
He drew on me.
Zach, you look free.
Yeah, I don't like that.
Those 2 triangles, the ones that we just did. Juniors, remember those for the ACT because those will help save and make shortcuts.
12.
No, you better get like a 25 in math because I know that you probably can.
Yeah, 'cause you're smart.
You are a pretty decent math kid. Like your mental math is okay. Like honestly.
Okay.
I know. How good is my mental math?
You're pretty good at mental math too. Yeah.
3 times.
Very good.
Yeah. All right, here we go. Number 11. 11 is a 30, 60, 90 as well. Which side is your 1 side? 8. Which side's your 2 side? Y. So the Y should be 16 because it's double. There you go. Okay, this is your square root of 3 side. So 8 times the square root of 3, and that's it.
And we're done.
And we're done.
Oh, yeah.
Right? You're getting tired of writing? Same. I want to get done with this page. We only have 2 left. No, we have 2 left. I want to get done with this page. What?
We're done with that question.
What?
Yeah, we're done with the questions. Yeah.
Okay. Number 12. This is where it's going to get really icky. Sorry. Here you go. Write this down. They want us to find sine of J, cosine of J, tangent of J. Put a line. Sine of L, cosine of L, tangent of L, and put an equal sign after each one. And if you get done with that, start over with 13. Same thing. They want sine of J. They want cosine of J. They want tangent of J. And then they want sine of L. They want cosine of L.
We get it.
And they want tangent of L.
Yeah.
All right. I'm just making sure. Okay, there you go.
I'm done.
All right.
Shut up, Pat.
Now, shush, shush, shush.
Yeah.
Give him
Shush, shush,
that.
shush.
12, 13. Are we ready?
No.
Oh, fine, fine.
I'm sorry.
Okay.
Shit.
No.
What acronym do we use for this? Oh, yeah. Well, at least we know what an acronym is, all right. SOHCAHTOA. What does O stand for?
Opposite.
Opposite. What's H stand for? What's A stand for? Whoops. All right. Put a box around him. SOHCAHTOA. SOHCAHTOA.
Just use my brain.
All right. Okay. J. These first three are referring to just J, so I circle J. And when I'm looking at J, which side is opposite from J? 12. Which one is the hypotenuse? 20. Which one's the adjacent? 16. Okay, so when I do sine, I do opposite. Sine is opposite over hypotenuse. You see that? O over H. Sine, opposite over hypotenuse. What's the opposite? 12. Hypotenuse is 20. So it goes 12 over 20. Now, here's the deal, real quick. 12 over 20, we can reduce, we can divide by 4. So that is 3/5. All right, pause.
3/5.
Pause. We're going to have to reduce the whole thing. So here's what I'm going to do. Okay, go back over here.
We don't have to.
We don't want to reduce the whole thing because we're going to reduce it over here.
Oh my God.
So,
3, 4, 5.
12, 20, and 16, we can divide by 4. This is a 3,
7, 8, 9.
4, 5. I'm going to reduce them right there so we don't have to reduce them later, right? Okay. Cosine. Are we doing good? Cosine. Cosine is ca. A-H. So A goes on the top, H goes on the bottom. Which one is A?
3/5, just like the
4. H is 5. So cosine is 4/5. Okay? Tangent. Tangent of J. Tangent is TOA. OA. Which one's O? 3. And A is
Oh.
4.
Skip it.
Okay, now, they also want
black guy.
decimals as well. What's 3/5 as a decimal?
I can't.
0.6. Do you know that already?
I don't have enough space.
What's 4/5 as a decimal? 0.8. What's 3/4 as a decimal? That one you should know for sure. Okay, they want both of them. They want fraction and decimal, right?
Don't they want us to like
Brady, shut up.
No,
Gallon.
Shut
No.
up, Brady.
One.
not yet. Not yet. Not for that one. Okay. All right, now, here's the deal. We got to switch back to L, right? So instead of looking at J, are we all ready? Instead of looking at J, I'm going to erase J and I'm going to circle L, okay? But now my A, H, and O are in the wrong spots. But only my O and my A. Is H still in the right spot? Yep. So this guy is O and this guy is A, right? Okay? All right, sine, cosine, tangent. Sine is SO, S-O-H, right? S-O-H. What's O and H? 4 and 5. And 4 and 5 as a decimal is 0.8. Okay? Cosine is C-A-H, right? A-H is 3 over 5. And that is 0.6. And tangent. Tangent is OA. What's OA look like? 4 over 3, which is 1.33. Okay, now, FYI, just so you know, this is not a coincidence. This is not a coincidence. This is how it is always, right?
Okay.
Sine and cosine, they flip,
Yay.
right? Do we know that? What happens to tangent and
Reciprocal.
tangent and this tangent? They're the reciprocal, right? Okay, so there's that. All right, number 13. If we're looking at J, I'm going to have you guys do this, but I'll help you label.
No one does. What? No.
If we're looking at J, which is the O side,
Oh, blah.
Which side is the O side? 24. Which side is the H side?
Oh,
What?
blah.
And this is the A side. But before we do anything, hold on. Can we reduce? Can we reduce, folks? Yes. What do we divide by? Hey, what are we dividing by? Divide by 8. 3, 4, 5. Oh, wait a minute.
It's the same thing.
Guess what?
Chicken butt. 3, 4, 5. Oh, shit. This is
Brady, can you stop talking?
it. Please.
You wrote it all out. Huh? I'm going to cheat because I like to do that, right?
Oh.
It's the same thing, right? Because it's 3, 4, 5, and it reduces that way. Woohoo! Okay? Good. All right. Beautiful. All right. Okay.
No, we're done. Stop.
Here's what I want you to do right now. In the next 5-10 minutes that we have, you do number 24 and you do number 25. If you have to look back at your notes, go for it. But you write those in there. Go.
But we literally already drew and labeled.
I know we did. So you write them again.
I don't want to.
Okay? Do number 24 and 25 right now. Go.
What are the
Oh, I already did that.
What's the first Pythagorean triple?
3, 4, 5?
3, 4, 5. Okay? There's 4 others that I said to do.
4 others.
What? There is more than 4 others, but 4. Those 5 are the ones that are 2 digits or less. There are ones that are like in the hundreds.
5, 6, 9.
No.
5, 12, 13.
Okay, write them down. All right, there you go. Okay, goodbye, people watching this video.